Okay, so in this video, I'll continue what I was talking about for calculus, and I accidentally did make an error, which I have to address. But anyway, I wanted to actually give an example, a difference between instantaneous and average. So I have the function y equals 16t squared, and they're asking me to find the average speed during the first 3 seconds of fall. What would I do? Well, I would take 16. This is basic. Employment 13 is over there. Just like I'm taking this thing, and I'm going to subtract it by the other one. Well, I know that if it's only they only give me 3 seconds, then the other seconds must be 0 seconds because that's where it fell. So 16 0 squared over 3 minus 0, right? 3 minus 0. So that's the number of seconds. So that's 48 feet per second, right? So that was basic. That was just simple finding the average speed, which is kind of dull. Let's see what happens when they ask. They say, find the speed of an object at t equals 3. So not only are they telling me not to find the average speed, they're telling me to find the instantaneous speed, the speed of that object at that point. So y equals 16t squared. We already had that as the function. And so we have an object at t equals 3. So what do we do? Well, like I discussed the other day in the other video, that we need to use our limit. So I'm just going to use limit as h approaches 0. And so it says t equals 3. So t equals 3. That means that I take that whole thing, the 16t squared, and plug it in to 16 and parentheses x plus h, right, parentheses closed, minus f of x, right, all over h. That's basically what I gave yesterday, how to find the derivative. That's the same thing what we're doing. So it'll be 3 plus h. And the other video I made the mistake of putting it inside the parentheses, outside. The reason that we use the squared, why? Because this t is squared, right? So the f, they said, well, f is over here, right? And then x plus h. What's my x? My x is 3. My h is over there. And well, my f is here too. So where do I put the square? Well, I just put the square over here. And then we have minus 16 times 3 squared. Usually these ones turn out pretty nice, just saying. And this is all over h. So this would be minus f of x, right? Same thing, all over h. I have 16, so I would expand this out, generally. That creates, here, 144. And by the way, when you expand out, you have to use FOIL. So that's basically a basic algebra that you need to use for this. 144 plus 96. 96 is what came out at the end. This, I'm not showing the FOIL method. I'm not showing any of that distributing or anything. 96 h plus 16h squared minus 144. See, this is what I mean why it usually turns out nice. The 144 and minus 144 cancel out, right? And then I'm left with 16 all over h, right? This is all over h. So cancel this one, cancel a little bit. So 96 plus 16h is what I got. And well, what's the answer then? Well, if I have the limit h approaches 0, that means that this h is plugged in as 0, which basically takes out that 16. So basically it's 96. And that's just one of the general examples that we use in using limits and derivatives. So to continue, if they ever ask for the derivative of x squared. I might have said this, but it is 2x. And how do I show that? Well, it comes out like this. If I want the f, this prime symbol, x of x squared is lim as h approaches 0 of it. It would basically be f x plus h, right? And since it's going to equal x squared, what's my coefficient? It's 1, right? So I have no need of writing that f x plus h squared. Minus f, what's f of x? Well, f of x has to be x squared, right? X squared. And then eventually you expand this out, you get, like this, x plus h, x plus h. I don't really do the first hour. I do x times x plus h, and then I do h times x plus h, and x squared plus xh, or whatever you want to call it, plus xh plus h squared. So this means we have two of these, 2xh, right? X plus h squared. And then, well, what do we have on there? We have minus x squared. And I did forget that this is all over h. So these x squareds cancel out, right? Funny way that it always comes like that. Take out this h, take out this h, take out 1h. We have 2x plus h, right? And, well, h approaches 0, so means h basically 0. So we have 2x as the answer. And that's how I prove that derivative of x squared is 2x, using the derivative definition. You could also plug into your calculator. You could also know the power rule, discuss at a later time. And that's basically what I wanted to go over real quickly. Clear again. So I showed that also the derivative of x is equal to 1. Plug that in too. We also use derivatives for business as well. Like I showed you, we want the instant time, the instantaneous, what's happening at this time, not over time. Um, so I'm actually going to leave that business example for the next video, but basically just cleared up derivatives and such for you. So that will be all for this video. If you have any questions, please subscribe, comment, whatever you like.